In this talk, I wanted to basically just give you a high-level idea of all the different types of problems that we are dealing with, especially when you think about the consumer experience on the DoorDash app. So without further ado, let me dive into the talk. So basically, as you probably all have used DoorDash, I hope, you know that we're basically a technology company who is, really perfecting the last mile logistics, right? So basically, you have your merchants who wants better reach. You have the consumers who want the convenience of having something delivered to you, within minutes. And then you have the dashers who basically, are, getting empowered through the work that they're doing. And basically bringing these three marketplaces together is where DoorDash is at. And in each of these and in between, in the sense, in the connections between each of these nodes in the three-sided marketplace, AI has a very, very important role to play. And so I'll kind of touch upon that, and then I will dive a little more deeper into the consumer experience side of it. So the vision here is really to, connect every local business to every local consumer, right, and bring them things in minutes. And this is like a simple kind of a mission statement, but getting that done requires many, many things to be going right. And when you talk about connecting with every single local consumer, you have to think outside of the restaurants, right? So typically DoorDash started with restaurants, if you look at the history of the company, but essentially where a lot of our thrust is right now, it's in what we call the new verticals. And these new verticals are all the different things that that are non-restaurants, basically. So basically, you can order alcohol from the local alcohol store. You can, order food for your pets, and flowers and gifts, pharmacy, convenience, grocery. The list goes on. And if you think of this area of the new verticals, right? So if you think of a typical restaurant out there, a restaurant has 50 to 100 items on their menu. But when you think of this e-commerce space, right? Each of these, if you think of a Costco, for example, they have 200,000 items, right? So the cardinality of the items in the e-commerce space is huge, which means the flavor of algorithms and the way you have to build them is also fundamentally different from what we've been doing on the restaurant side. But at the same time, you want to actually have learnings from the restaurant side flow into these new verticals. And I'll touch upon these as I go through the talk. So talking about this three-sided marketplace, right? So if you just imagine, this is for specifically, say, the new verticals use case. But if you just imagine that the merchant here at the top were a restaurant, right? It was a much more simpler problem back then. So basically, the dasher would go and pick up the already prepared food. Right now, we have this kind of a paradigm shift where the dasher themselves have to go and do the shopping, right? So this brings in a lot of different new flavors in which AI can be used in this three-sided marketplace. So let's talk about the consumer, right? So the consumer is going to a grocery store on an app which has a small real estate on a mobile phone. So there, it's extremely important that you help that consumer parse through these hundreds and thousands of items that this store may carry. That then means it has to be very contextual to the consumer. It has to be personalized. And the consumer might go and search for things that they don't see on the homepage. The search has to be extremely good and fast and accurate. And then the consumer might place an order for something that's running low in the store, right? And you should give the consumer an opportunity to choose substitutes. And that's another recommendation system in the sense that it's a recommendation in the context of the item that's running low, right? And then you think about the dasher, right? So the dasher goes to the store. We have to be extremely sure that all the product information that's in the app, in our catalog, are correct, right? And this, you can leverage a lot of AI to do. There is also humans in the loop in that system, and I'll talk about that. But essentially, you can speed up what humans can do with AI. And then there are the two other, vertices of this triangle. So one is, between the dasher and the merchant. And there we have a lot of applications of AI, which is about how do you dispatch the dashers, basically, and how, the batching algorithms that go there. How do you actually make the dasher shop efficiently, right? That's where also AI can have a lot of leverage. How do you decide the pace? Again, substitution and fulfillment. This is where, as the dasher is shopping, something is running low. Can we show the dasher like these are the good substitutes? Between the dasher and the consumer, it's basically a play of supply and demand, and the consumer wants things in a certain amount of time. So it's also about fulfillment, and there's a lot of ETA prediction and those types of problems on that vertex. What my team works on is actually the top and the right-hand end. So basically mostly on the bottom right, which is the consumer who is using the app, and then connects that experience, makes that experience better, right? This is my team right now, very, very bright and talented individuals working on a lot of deep learning problems. And I'm sure I'll talk about some deep learning because this is Deep Learning Summit. But our mantra is, as a consumer, DoorDash not only gets me the things that I want, but also gets me in the sense that it understands who I am as a consumer, right? So if you take out all the other things from this triangle, then my team right now is concentrating on these two aspects, which is getting the product informations in the catalog right through ML and humans, and then getting the consumer experience on the app personalized, contextualized, and making the app extremely easy to use. And basically the idea is that you should be able to complete your basket in a very small amount of time, but also not pigeonhole you into things that you normally buy, also have an element of serendipity, diversity, thing that you're asking before, right? So how do we do that, right? So basically, it all starts with what I like to call understanding the consumer's persona, right? And this persona is not a static thing, it evolves. But essentially, to make my experience on the DoorDash app better, you have to understand my tastes and preferences that you can implicitly discern from my previous shopping behavior. You can go and also ask, right, are you a gluten-free person? And then habits and idiosyncrasies, right? So maybe, every Friday evening I order alcohol. So I can pick up on that habit. My dietary and lifestyle preferences. I may have certain brand affinities, right? So I only have Strauss organic milk yogurt, right? So understanding those things. And then it also helps me, that persona needs to understand that I also am not a person who just have these 5 things that I always buy, but it doesn't mean that there's these 20 other things that I would discover if I walked into a physical store and also buy. So it has to have that element of serendipity and discovery for new items baked into this. It also has to anticipate my need state right now. And as I was saying, if I have, just ordered a pizza on a restaurant, maybe I can also add a wine that goes with it. It also has to evolve, right? So this is one of the things that, talk about Netflix, talk about any other, personalization company. No consumer is a static, vector, right? They're evolving as they're using your app. And so the system has to evolve, right? And then also it has to be very careful of not pushing irrelevant things to me. If I don't have a pet, for example, so why show me a pet food row, right? So basically, all these things together is what makes the experience very personalized and also contextual and also evolves as I evolve, right? And deep learning plays a very central role in getting this persona right. And I'll touch upon how we're doing that. But let's talk about the surfaces on which these models work, right? So basically, you go to this app, go to this store. You can go to a category inside a grocery store like bakery, right? And there are probably 6,000 items in the bakery or 600 items. So this is inherently a ranking problem. This is a personalization ranking problem where I need to know a certain expression of the item that I'm ranking and how close it is to the embedding or the expression of you as a consumer. So I can actually only show at the top the things that are relevant to you. As you're building the cart, as I said, as you're kind of about to check out, if I see that if you actually shopped for the ingredients of making pizza, for example, you have shopped 00 flour, you have shopped tomato sauce and pepperoni, I can also suggest that, please add some wine. things like that. So basically complementary item. If you shop for milk, I can say, add cereals. So that's another sort of flavor of, recommendation system that we can build based on item embeddings, like how items are complementary to each other. Then there's the substitution recommendations, which is more about how items are similar to each other. So, this one thing that's missing, what can I substitute it with, right? And then there is the collection ranking and generation of collections. So this is where it's kind of like, I have these 20 rows, and this is where like in the physical world, if you think about it, if you go to a physical grocery store, it's a humongous store, say, but every consumer has their own personalized way of navigating the store, right? So if you are if you're a vegan person or a pescatarian person, you'll probably not walk by the meat aisle, right? So how do we make that happen inside an app? So in the app, the equivalent is that the rows that we show, that has to be ranked in a way that's very relevant to you. So we're not showing the meat row to the vegetarian person, and this is powered again by personalization. And then going ahead, there is also the question of how do we rank the items horizontally within the rows? Because each of these rows, like, for example, the discounts and more. So there's a lot of things that a grocery store might have on discount right now, but most of them may not be relevant to you. So that, again, needs to be personalized and ranked in a certain personalized way. And then we have this other surface called DoorDash. So basically, after you have ordered something from store 1, we give you 10 minutes to add another item from store 2, which is nearby. So the same dasher can pick it up, right? And this is, again, a very contextual recommendation problem. So I've ordered, again, like you say, maybe, like I've ordered a few things from a convenience store that says that, I'm probably celebrating a birthday or something. Then I can actually recommend to you that here's a cake shop nearby and pick up the cake for you. So basically, all these experiences are powered internally by certain embeddings or understandings of what an item is and what a consumer is. And that's where deep learning shines, because you can discern those things through embeddings, right? So that was the sort of browsing experience. But if you think about it, going back to the last talk about LinkedIn search is also very important, because there is always going to be something that's not on that page that you need to search for. And in search, there's this kind of a little bit of relevance to the query and relevance to the consumer, right? So first, when you're searching for eggs, I don't want to see broccoli, right? So it has to be relevant. But then, if I search for eggs and if I always buy this particular brand or particular size of eggs, the system needs to know that I need to bump that up towards the top, because that then reduces my scrolling and scanning time, right? So basically, it's a relevance problem first. So this is sort of like the L1 and L2 that the last talk was talking about. And then there's a personalization on top, right? So, and it's extremely important when you're doing grocery shopping, right? And then you can also think of autocomplete as another way of quickly enabling the consumer shop. As you're starting to type gran, we can understand that you're shopping from granola, right? So behind all this, though, one thing that makes or breaks all these experiences is that if you don't have the correct taxonomy, if you don't have the correct attributes for the items, and that is where we are also applying a lot of ML in deciding things like, okay, this fuzzy cola can 12 ounce that the merchant said. So every merchant has a different way of saying the same item, right? So you have to actually go and basically figure out what's the canonical version of that item that I can then put into our taxonomy, into DoorDash's own catalog. So it becomes sort of like an entity resolution type problem. But also you can have situations where everything else is correct, but the image is wrong. How do you detect that, right? So basically, this is where also, again, deep learning shines, because you can actually look at the name it's embedding and the photo is embedding. And if something that looks like shrimp has been tagged as cod, a completely different fish, we can quickly detect that. And this is exactly where human in the loop type machine learning systems really shine. And you're also starting to leverage some large language models here, because large language models are extremely good at extracting things like brands and stuff from long item names. So how do we get there? So this is like where I'm getting into the deep learning side of it. And essentially, we start with representation learning. So as I said, each item and each consumer has a certain embedding that has to cross the boundaries of the verticals and cross the boundaries of the different merchants we have. And you can think of different tasks that you use to learn these embeddings. For search, you could look at what they're clicking on, what they predicting that, or what they add to cart, predicting that, and learning a representation of this first item, which is this carton of eggs. But you can also think of using the text and the image to learn another type of embedding, like say a clip embedding for this item. On the other hand, we could also learn embeddings from looking at what consumers have historically substituted between two items, right? So this is where something like a sentence BERT can be very useful, because you can look at the two items and can say, these are very similar in the embedding space, and therefore I can use that to use a certain type of embedding. So once you've learned that, you can either look at the consumer's past behavior, like what they've bought in the past, and create an average embedding of the consumer, or you can actually learn a consumer's embedding end-to-end within a machine learning model. And we do both. So coming to the models, right? So different surfaces, and all these surfaces that I showed you, they use different types of this. There's a zoo of models, and they have different purposes within the app. And the deep cross network, for example, it's extremely good for like the search ranking problem and the recommendation problem too. And we use it situationally where it shines the most. As the last talk was saying, there's this you have the deep part, which is the embedding side, and then you have all these wide kind of features that you want to interact with the rest of the features. And this is where wide plus deep type of networks are very good. There is a graph, element to everything we do at DoorDash, because the product graph is a graph. This brand carries this thing, blah, blah, blah. But then you can also think of the consumer shopping behavior kind of expressed as a graph. And you can say, I want to predict something like, where is the next customer going to shop at, as a link prediction problem. So we are also looking into, graph convolutional networks and other graph-based methods to do those kinds of predictions. BERT, again, it's just an example of one of the NLP techniques we use, but fine-tuning BERT to understand what an item name really means through different tasks is something we also use. That one actually is very useful in the query understanding space, where you can say, here is the query, which is light roast coffee beans. What is the key term here? What's the modifier, right? Light roast is a modifier. So understanding those kind of nuances. And then we have the deep, recommendation systems, deep learning-based recommendation systems, which are also using to personalize all the surfaces that I talked about. And last but not the least, we have the human-in-the-loop ML, which is, as I was saying, is kind of essential in the e-commerce space, especially when you think of the side of the business that's creating the taxonomy and the catalog, right? So merchants are coming onto the DoorDash platform. They have their own taxonomies. They have their own way of labeling items, but they have to go into our version of the catalog, and has to be canonicalized, sanitized, and all those things have to happen. And then so this is where you need a taxonomist who decides how the taxonomy tree looks. So a human is necessary, but then how do you tag items onto that taxonomy? How do you extract attributes like, this item is organic, this item is gluten-free, this is a 6-pack of Coke? Those things are actually pretty easy to do with a first-pass algorithm and then showing to the human, right? And this is where we're employing a lot of these human-in-the-loop algorithms, where the algorithm first goes and makes 5 predictions. We show the 5 predictions. The human says the first one is correct. Then that goes back into the training level next time, and that reinforces the algorithm. And so at the end of the day, the algorithm becomes better, but also the human amount of work reduces. So that's actually a win-win situation. And the last idea I would like to leave you with is that there are certain other emergent areas. Obviously, everyone is very excited about large language models, and we are looking into using those too. But another thing is causal inference. And causal inference is where you can actually measure the causal effect of an impression, the incremental effect of an impression of a certain thing like an ad, right? And when I explain this, I use this example. It's like, maybe I'm like, I always order alcohol, right, on a certain day. And so if you're showing me this ad, like if I was going to anyway order alcohol, showing me this ad, it's fine. But the thing is, another purpose of the ad is to actually get someone who never ordered alcohol to order alcohol, right? So basically, what's the incremental value of showing this ad to someone? And if you were to actually, from the first principles, attack that problem, it will be a causal problem. So does that impression cause me to place the order? And what is confounding there is like the thing that, it's my own affinity for alcohol, right? So if I have high affinity for alcohol, then that ad is kind of a little bit wasted on me. So do these types of like targeting things, we're looking at, sort of developing some causal inference methods. And as I said, large language models we're looking at for kind of parsing long queries, understanding queries, helping with taxonomy, tagging tasks. So yeah, like this is the sort of like the full gamut of the different algorithms that we're using. And goes without saying that classical methods are still very good, but deep learning becomes essential when you have to have these sort of embeddings and expressions of items and consumers, and you have multiple verticals through which you have to do cross learning, right? So yeah, I'll just leave you at that, and thank you for this opportunity.